Hello class, and welcome to this lesson on prime numbers and prime factorization. Okay, so first off, what is a prime number? This is something we've talked a little bit about in class already. You should know that a prime number is a number that has only, now I want you to fill in the rest. Pause the video and think about that and see if you can come up with the answer. Okay, you should have said something like, a prime number is a number that has only two factors. And if you wanted to be real specific, you would say 1 and itself. For instance, 7 is a prime number because the only factors of 7 are 1 and 7. So therefore 7 is a prime number. Let me ask you to decide if 9 is a prime number. 9. Prime number, yes or no? Pause the video and think about that, and unpause and see if you're correct. Okay, the answer is no. 9 is not a prime number because think about the factors of 9. We'd have 1, 3, and 9. And just because we have even just one additional factor besides 1 and 9 itself, even if a number has just one more factor like this one does, it has the number 3, has one more factor besides 1 and itself, so it is not a prime number. What we would call this number is a composite number. Every number that is not a prime number is called a composite number. So we only have two choices. All numbers are either prime or composite. Okay, let's try another challenge. Is the number 11 prime or composite? Pause the video, figure that out, and then see if you're correct. Okay, 11 is a prime number because the only factors of 11 are 1 and 11, so it's a prime number. How about the number 15? Prime or composite? Okay, 15 is a composite number because the factors of 15 are 1, 3, 5, and 15. So remember, all it has to have is just one other factor besides 1 in itself. If it has even just one other factor, then it is going to be a composite number. What about the number 16? Prime or composite? 16 is composite. And you probably have started to figure out by now that if a number is an even number, that right away you know it's a composite number because it's going to have a factor of what? See if you can come up with that answer. Okay, hopefully you said that all even numbers are going to have a factor of 2. So you know 16 is not prime because it's going to have a factor besides 1 in itself. It has the factors of 1, 2, 4, 8, and 16. So all even numbers, well, all even numbers except for 1 are going to be composite. Pretty much all even numbers are going to be composite because they're going to have a factor of 2, except for 1. There's one even number that's actually prime, and it's the only even number that's a prime number. Pause the video and see if you can figure out what that one even number is. It's a very special number because it's the only even number that's prime. All other even numbers are composite. What is it? The answer is 2. 2 is the only even prime number. Can you figure out why 2 is prime even though it's an even number? The reason that 2 is prime is because, think about it, what are the factors of 2? 1 and 2. Well, look, the only factors are 1 and itself, and that's the definition of a prime number. A prime number is a number that has only 2 factors, 1 and itself, and that's all that 2 has. It only has 1 in itself, so even though it's an even number, it's prime. But remember, every other even number in all the numbers are going to be composite. Now, does that mean that every odd number is going to be prime? Yes or no? No, that doesn't mean that every odd number is going to be prime. In fact, we had one earlier in the video, the number 9. That's an odd number, but it's not prime. Its factors are 1, 3, and 9. It has more than just 1 in itself. So, not all odd numbers are prime. But the only numbers that could be prime are odd numbers, except for 2. Remember, that's the only number that's even, and it's a prime number. Okay, for the last part of the lesson, today we're going to talk about prime factorization. Did you know that every number can be broken down into prime factors? For example, let's take the number 12. Think of 2 factors that you can multiply to get the product of 12. How about 4 and 3? Are either of these prime, 4 or 3? Hopefully you said yes, 3 is prime, and so I'm going to circle it. Every time, what I'm creating right here is called a factor tree. Sort of looks like branches coming down from a tree. As we branch down, we're going to branch down in a second here off the 4. So every time when you're creating a factor tree, every time that you come up with a prime factor, go ahead and circle it, because you're basically done with that. We're done with the 3 now. However, we're not done with the 4 because it's not a prime number, so we need to break it down more. 4 could be broken down into the factors 2 times 2. 2 times 2 equals a product of 4. Is 2 prime? Yes, you learned earlier in the lesson that 2 is the only even prime number that exists. And there we go, we're done, because all of the numbers on the bottom of the tree are circled because they're all prime. So what you would do now is you would take these prime numbers and you would write them in order from least to greatest with multiplication signs in between. So here, so I've got my first 2 right here times the second 2, which is right here, times 3, which is this last prime factor right here. And that's all of them, 2 times 2 times 3. Because see, if you took 2 times 2 times 3 and you actually worked it out to find the product, 2 times 2 is 4, and 4 times 3 equals 12, which was our original number. So we took 12 and we broke it down into, eventually, all prime factors. And then we write those prime factors down like this. So if I asked you to give me the prime factorization for 12, you would say the prime factorization of 12 is 2 times 2 times 3. These are the prime numbers that 12 can break down into, that if you multiplied them, they would equal 12. One more cool thing about breaking down a number using a factor tree is that it can be done different ways. In the last one, we started off by breaking 12 down into 4 times 3. But what if I wanted to do 6 times 2? 6 times 2 equals 12, so that works fine. Do I have any primes yet, 6 or 2? Yes, 2 is prime. 6 is composite, so we need to break that down more. 6 could be broken down into the factors 3 times 2. Are those prime? Yes, 3 and 2 are both prime, so again, we're done. Now, remember, I want to take these prime numbers and put them in order from least to greatest with multiplication signs in between. So I'll start off with this 2, and then I'll do this 2, and then finally the 3. And again, I still come up with 2 times 2 times 3, which was the same prime factorization I came up with in the last example when I broke 12 down into 4 times 3, and then 2 times 2. I still got 2 times 2 times 3. So as you can see, anytime that you take a number and break it down using a factor tree, you can do it different ways. And as long as you're using correct multiplication, you'll always get the same prime factorization. Let's end with a couple of challenges. Try to find the prime factorization of 16. Remember to create a factor tree. Okay, hopefully you broke down 16. You could have broken it down into 8 times 2, or I'm just going to go with 4 times 4. Neither of those are prime, so they're both composite, so I need to keep going. 4 can break down into 2 times 2. Those are both prime. And I'm also going to break this 4 into 2 times 2. And of course, those are both prime. So the prime factorization for 16 is 2 times 2 times 2 times 2. Now try to find the prime factorization of 27. Okay, pause the video again and work on that, and then see how you did. Okay, for 27 we only have one choice to break it down to start off. We need to do 9 times 3, or we could do 3 times 9. Either one of those would be okay. So I'm going to go 9 times 3. Are either of those prime? Yes, 3 is prime, so we're done with the 3. 9 is composite, though. We need to break that one down. And we could break that into 3 times 3. Oh, here's something that you don't ever want to do. I almost forgot to point this out. Don't ever break a composite number down into 1 times the same times the number that it is. Like, what I'm saying is don't break 9 down into 9 times 1. That's not going to do you any good, because sure, you could circle 1 because it's a prime number, but then you're still going to have to break down 9 again. So you're really just doing an extra step. So don't ever do that. Okay, so let's break down 9 into 3 times 3, and those are both prime, so let's circle them. And so here we go. The prime factorization for 27 is 3 times 3 times 3. And again, we should check our work. So I could multiply 3 times 3, and that's 9. And then 9 times 3 equals 27. Whenever you find your prime factorization, multiply the numbers together. You should always get the number that you started with. If you don't, then you might have a factor that's missing here in your prime factorization if you don't come up with the original number. So it's a great way to check your work. Okay, so that's it for this lesson on prime numbers and prime factorization. Make sure that you look below the video there on Edmodo and check for the follow-up task that you'll be asked to do. And make sure you read the directions carefully on that. And come to class prepared in the morning. Okay, thanks for watching.